All right, and welcome back, Pre-Calc. Today is our last new lesson on this Chapter 4, a little mini chapter that we're doing after fall break. So just a reminder that tomorrow then is your day to work on the review. It's at the back of the packet, and if you want to start it today, that's great. Those answers will be posted tomorrow at 3:20 on It's Learning in Google Classroom, and then on Friday your quiz will go live at 7:30, so make sure we get that done by Sunday at midnight. But I strongly recommend just take care of business on Friday so you don't have to worry about it. So if you have any questions, please reach out, let me know. Today, our final thing, we're going to take what we learned yesterday and we're going to apply it. We're going to figure out how do we graph these functions. Okay, so step 1 here says we need to find our vertical asymptote and draw that line. So when we're looking for our vertical asymptote, I'll put this over here on the left. I'll put VA. To find our vertical asymptote, remember we take the bottom and we set it equal to 0. So x minus 3 equals 0. Go ahead, we can add that 3 over, which will mean x equals 3 is our vertical asymptote. So now I want to draw that in. X equals 3. We go on the x-axis to 3, and then I draw this vertical asymptote in, and step 1 is complete. Okay, step 2. So I'll do this one in red so it maybe stands out. Step 2, we need to find either the horizontal asymptote or an oblique asymptote, depending. Okay, so to find the horizontal or oblique asymptote, first thing we want to do is check what are the degrees. So on the top, it's degree 1. On the bottom, it's degree 1. So that is the same on top and bottom, which if you don't remember from yesterday, you can look back in your notes. But when they have the same degrees, we know it's y equals. We know it's going to be a horizontal asymptote, and we take the leading coefficient. So right here in front of the x, there's nothing on either one, so that means it's 1 over 1. So our answer, y, let me put this over here so I save space, but our answer would be y equals 1. And so go down here and we'll circle it's a horizontal asymptote at y equals 1. Go on your y-axis and we can go through at 1, and we'll draw that horizontal asymptote in, and we're done. Okay, so now finally, step 3. To do step 3, we need to pick a point on each side of the vertical asymptote and plot this so that we can tell, if you look over here, we don't know which quadrants it's going to be in. So when I say pick a point on either side, our vertical asymptote occurs at 3. So if we draw that was not good. If we draw our number line here, we know 3. Now go 1 to either side, that's 2 and 4. Those are the points we're going to use. We know the x value will be 2 on this one, the x value will be 4 on that one. Now, we're going to plug that into our function here. So we're going to plug the 2 in for both of the x's. So if I solve it, it'd be 2 minus 5 all over 2 minus 3, which 2 minus 5 gives us negative 3 over negative 1. Negative over negative becomes positive, so we get positive 3. So 2, 3. And then I can go over 2, up 3, and I'll put a dot right there. Okay, and then the other one, we plug in the 4, so it would be 4 minus 5 all over 4 minus 3. 4 minus 5 would be negative 1. 4 minus 3 is just 1, so we get negative 1 as our answer. So 4, negative 1 is our next point. So we go over 4, down 1, put a dot. Now, we said yesterday that our asymptotes are lines that it approaches. Okay, so now from the point, we just approach both of these asymptotes. So when I say it approaches, I mean it comes up towards and approaches it, put an arrow on. It comes down and approaches it, puts an arrow on. Likewise, it comes up towards and approaches it, put an arrow on it, comes down towards and approaches it, put an arrow on it. And while this graph is not exactly perfect, we are going to say that this is good enough representation of what we have here. Okay, so today on the It's Learning assignment, you're going to have to do all of this part. You're not actually going to have to graph it, but you are going to have to do this part. So make sure you understand how to do it and follow along. We've got a few more graphs to do. So let's do number 2 together. Remember, first step is finding our horizontal asymptote. Okay, our vertical asymptote. So to find the vertical asymptote, once again, just set x minus 4, whatever the denominator is, equal to 0. We add the 4 over, and we'll get x equals 4. That's our vertical asymptote, and so then we go on the x-axis to 4. We draw that in. And step 1 is done. All right, so step 2 now. It's either going to be a horizontal asymptote or a oblique asymptote. We have to decide. Now, to figure this out, once again, we take our degree. Okay, so degree 0 over degree 1. So it's low over high, which anytime we have low over high, then we know right away that it is a horizontal asymptote and it's y equals 0. That is always the case when you have a lower degree over top of a higher degree. It's always at y equals 0. So y equals 0 is when it crosses the y-axis at 0. Another name for that line, y equals 0, would be your x-axis. All right, so there we drew it in red. Okay, so now the final thing we need to do is establish what our points are, so we can figure out which of these four quadrants the function exists in. So once again, what I recommend you do, take your vertical asymptote, which in our case is 4, go 1 to either side, which will be 3 and 5, and those are the points I care about. Plug it in a 3, plug it in a 5. Now on the last one we had to plug it in 2 times. Here we only have to plug it in for the x, so only have to plug it in 1 time. So on the top we'll have 3 over 3 minus 4, which will give us 3 over negative 1, or negative 3. So 3, negative 3, go over 3, down 3, that's 1 point. Our next one, if we plug in a 5, it'll still be a 3 on top, 3 over 5 minus 4, 3 over 1, which is just 3. So 5, 3 is our other point. So over 5, up 1, 2, 3. All right, and from here, all we have to do is approach. So remember, it approaches. We know it approaches this one. Oops, let me fix that. And it approaches that asymptote, and then likewise approaches that asymptote and also the vertical. All right, so go ahead and flip it over now, and we've got 2 more of these to do. If we look at this next one, the first thing we want to do is our vertical asymptote. So once again, all we got to do is take the bottom, set it equal to 0. This one is really easy because it is already solved. X equals 0. So another name for that would be your y-axis. So hopefully you can see that, but I'm drawing in right over the y-axis. And there we go. All right, so now our next one, we have to decide, is it a horizontal asymptote or a oblique asymptote? And the way we can decide that, once again, we're going to decide the degrees. So it's degree 2 over degree 1, which is our high over low, and it's high over low by just 1, which means we are going to have to use long division. It is going to be an oblique asymptote we're going to use long division to find out what that equation is. So we set it up, x squared, don't forget the x goes out front. Don't forget we have an x term in here, so x squared plus 0x minus 1. So to get it here, we'd have to go x. So x times x would be x squared. We'll subtract. If we bring down, it'll be 0x minus 1. It's up to you. If you want to, you can say x plus 0. We wouldn't technically have to have that, but 0 times x is still 0x. So we'd get negative 1 as our remainder. Okay. So don't forget then when we write our oblique asymptote, it's either y equals x or y equals x plus 0 if you prefer. That means it has a y-intercept at 0, so right here, and the slope is 1, so we know it's going to go up to the right. It also will go down to the left. And there we go. Now, we still need to find our points. Even though this is an oblique asymptote, there's still 4 different quadrants it could exist in. And we're going to figure out which 2 it exists in. So once again, we take our vertical asymptote, and that was at 0. So we go 1 each way, 1 and negative 1. And let's plug those in. You're going to have to plug it in 2 times for the x squared and into the x. So the negative 1 squared minus 1 all over negative 1. That's the same as negative 1 squared becomes 1. So 1 minus 1 over negative 1 is just 0 over negative 1, which gives us 0. So our point is at negative 1 comma 0. So negative 1, 0 would be right there. And then I'm going to do the same thing now. We got to plug in a positive 1. So once again, it'll be 1 squared minus 1 all over 1. This time we'll get 1 minus 1 over 1, which gives us 0 over 1, which once again gives us 0, 1, 0. So 1, 0 is right there. And now we just need to take both of those and, let's approach the asymptote. And then approach this asymptote, it goes up pretty quickly. And we are done. So I'm going to do one more with you. If you need more time, pause the video, take a look at it. The last one, so once again, we always want to find your vertical asymptote. So to find our vertical asymptote, all we got to do is set the bottom equal to 0. So x plus 2 equals 0. Subtract that 2 over, and we'll get x equals negative 2. So we go here to negative 2 on the x-axis and draw the line straight up and down. Okay, so now we need to decide, is it horizontal or oblique? So horizontal or oblique. Once again, we got to check the degrees. Degree 2 on top, degree 1 on the bottom. So that's high over low by a degree of 1, which means we know it is going to be oblique. And once again, we need to do some long division. So out front, we're just going to have the x plus 2. Inside, x squared plus 3x plus 4. Double check, are all the slots represented, and x squared, then x, then a constant, so we're good. So now, all we have to do is start what times x gives us x squared. That would be x. X times x is x squared. X times 2 is 2x. Now we do the opposite of both of those. And we subtract down, we get x. And we drop the 4, so x plus 4. At this point now, once again, we need to know what times x would give us x. So that'd be plus 1. 1 times x. 1 times 2. We're doing the opposite, so both of those become negative. And we would get 2. X cannot go into that, so that is a remainder. but we don't actually care about that. All we care about is right here at the top, the x plus 1. So y equals x plus 1. That is our coefficient, or sorry, not our, that is our oblique asymptote. Sorry, that took me so long to get out. So we start here at 1. That is our y-intercept. It goes up to the right, or it can go down and to the left. And we are done. Okay, so now all we have to do, the final step, is find our points so we can figure out which of these quadrants it exists in. So once again, it started off, our vertical asymptote was -2, so go each way 1, so -3 and -1, and those will be our points. We got to figure out, this one is a little bit more complex. Okay, we're going to plug it into that. So let me zoom out a tiny bit so I have a little bit of room here. Okay, so right here, x squared plus 3x plus 4 all over x plus 2. So if we plug in the -3, be -3 squared plus 3 times -3 plus 4 all over -3 plus 2. So -3 squared would give us 9. 3 times -3 would give us -9 plus 4 all over -3 plus 2 gives us -1. 9 minus 9 is 0, plus 4 gives us 4 over -1, or -4. So -3, -4 tells us we'll go -3 down 4. We'll be right in that quadrant. And now we need to do it again, except this time we're going to plug in the -1 up here. So once again, -1 squared plus 3 times -1 plus 4, all of that all over -1 plus 2, and -1 squared is 1. 3 times -1 is -3 plus 4 all over 1. We combine combine the top, 1 minus 3 plus 4, that will give us 2 over 1, which equals 2. So -1, 2 is our other point. And now let me zoom in to finish this out. So, a little too far. So to finish it out then, we just approach the asymptotes on, it approaches both of them from each point. And that is what our graph looks like. So once again, on today's assignment in It's Learning, you're not actually going to have to show me a picture of your graph. However, you are going to have to find your vertical asymptote. You'll have to decide, is it horizontal or oblique? And then tell me what that is. And then you're going to have to find out what the 2 points would be to tell you which quadrant it is. So please let me know if you have any questions. You can go ahead and start on the quiz review. You know everything to do it now. So if you want to just knock that out today, then you don't have anything to do tomorrow. But once again, hope you guys have a great day. Bye.